Hello students, in this video we are going to talk about general organic chemistry. Now this is simply called GOC and the name of the chapter given in your textbook is Basic Principles of Organic Chemistry. So this is the introductory first video of organic chemistry. We start with what is organic chemistry. Now organic chemistry is study of carbon and its compound. Now, for the purpose of understanding carbon and its compound, now you consider periodic table. In this periodic table, we have carbon located somewhere here. You must be familiar with periodic table. For understanding this structure of carbon compounds, we need to first understand what is carbon or how is carbon forming bonds. For the purpose, let's start with this simple introductory understanding carbon atom. Now this carbon atom represented by this C has atomic number 6 and mass number 12. Now what is atomic number? Atomic number is number of proton in the nucleus, and mass number you can call atomic number as number of electron outside the nucleus also. So there are two definitions: number of proton inside the nucleus or number of electron outside the nucleus. Now what is mass number? Mass number is number of protons plus number of neutrons. Now number of protons and number of neutrons inside the nucleus will form this mass number. Then for the carbon atom, atomic number is 6 and mass number is 12. Then we'll draw carbon atom in this atomic representation. First of all, this is suppose the nucleus of carbon atom. Then in the nucleus there are 6 protons and there are 6 neutrons. As you all know, proton carries positive charge but neutron is electrically neutral. It has no charge. So this nucleus will be filled with protons carrying positive charge and neutrons carrying no charge. Then this nucleus will be positive. Then as we know the configuration, electronic configuration of carbon as 2, 4. That means in first orbit there are 2 electrons and in second orbit there are 4 electrons. Then we'll continue drawing this carbon atom. In first orbit we are showing these 2 electrons and in second orbit we are going to show 4 electrons like this. Now I am writing electron as negative because electron carries negative charge. Now in this representation or carbon atom structure, you have to understand last orbit, that is outermost shell, or we can also call it as orbit or simply known as valence shell. The electrons that are participating in any bond formation reaction will be from this, essentially from this outermost orbit. Then if you understood this atomic representation of carbon, this is neutral carbon atom. Now this neutral carbon atom means there are 6 protons inside the nucleus, and there are 6 electrons outside the nucleus or revolving around the nucleus. Then you remember this rule from your previous knowledge, octet rule. Now, what the octet rule states? Octet rule states that every element try to gain, lose or share electron in order to complete octet. Now, in order to complete octet means every element tends to get stabilized, tends to get stable by completing octet of electrons. Now, this is simply the octet rule. Then you have to think of this carbon structure, again a representation of atomic carbon. 4 electrons are there in outermost orbit, and in according to octet rule, carbon will behave or follow the octet rule, and it will try to or tend to get 8 electron in its outermost orbit. For the purpose, let's show carbon in this new representation, that is electron dot representation. Electron dot representation. Now in this electron dot representation, we are going to show carbon, and we are actually going to show only valence electron, that is electrons that are residing in outermost orbit. If it is so, then carbon with these 4 electrons will be our electron dot representation of carbon. Then let's understand this tendency of carbon to get 8 electrons by seeing the example of this CH4 molecule. CH4 is simplest of all the organic compound. CH4 is basic hydrocarbon. Then for understanding the structure of CH4, first you understand this basic rule. Organic compounds are covalent compounds. Organic compounds essentially, whenever they will take part in bond formation, they will be covalent in nature. Then this carbon will try to share its electron, 4 electrons, in order to get 8 electron in its outermost orbit. Suppose this is the electron from hydrogen. Then hydrogen carries only 1 electron because it's having atomic number what? 1. Then its first orbit will contain only 1 electron. Then carbon will form essentially this covalent bond which is getting formed, and due to this sharing of electrons, hydrogen is also getting benefited by completing its duplet. This hydrogen is also now only to make different appearance, these electrons are shown like cross and dot. This cross electron represents carbon and dot electron represents hydrogen, but there is no difference in structure or properties of electron. Electron will still be the same. This hydrogen will give 1 electron here, so this 2 electron bond, every bond carries 2 electrons, every single bond carries 2 electrons. Then hydrogen is getting benefited by completing duplet of electron. This hydrogen is also getting benefited by the duplet of electron. If it is so, then carbon is getting 8 electrons. These are basically the shared electrons. So we can show the octet of carbon by drawing this circle. That means carbon is completing or getting 8 electrons, thereby satisfying the octet rule, or thereby satisfying its natural instinct of getting 8 electrons in outermost orbit. Now this electron dot representation of CH4 molecule will be like this. Suppose, for understanding, again, what we are trying to do in this lecture is understanding carbon atom. Now carbon atom, as you all know, this is what carbon atom having atomic number 6 and electron configuration 2 4. This carbon atom is always forming 4 single bonds. If it is this methane molecule, we are going to show it like this, and each bond will carry 2 electrons, one from hydrogen and one from carbon. If it is so, then carbon is getting 8 electrons in outermost orbit, thereby completing octet, and hydrogen is getting 2 electrons, thereby completing duplet of electrons. Then let's consider this structure of CH4 first. I am going to show you three-dimensional view of this CH4. Then you will understand why these organic compounds are three-dimensional. Now this CH4 molecule, as it is molecule, is three-dimensional. Now in representation or in three-dimensional way, CH4 will exist like this. See one bond like this, because in plane of paper, this plane of paper where I am drawing is 2D. Then if we have to show 3D structure of this CH4, then you consider these three lines as the exact same 3D structure. We have to show like this. This is the hydrogen, this hydrogen, this hydrogen is going towards you. That means this carbon is in the plane of paper, this hydrogen is also in the plane of paper, this hydrogen is also in the plane of paper. But as it is 3D structure, this CH4 always exists in 3D structure. This edge that is projecting towards you and another edge that is going away from you. This kind of representation, carbon is showing 3D structure. Molecule is showing 3D structure. 2H are in the plane of paper and 2H are away from the or towards the observer or away from the observer. Now to understand this CH4 3D representation, you need to understand this cube. Suppose I am drawing an imaginary cube for three-dimensional visualization. Then this CH4 molecule that I am stating that it is three-dimensional, carbon will reside in the middle of the cube. Then you have to understand these two corners. These two corners will each carry hydrogen, and these two corners will each carry hydrogen. If you take a combined look of this, then you will realize that carbon is in tetrahedral fashion. Now what is this tetrahedron? Tetrahedron, if you try to draw or connect each of this hydrogen, you will end up with this messy structure that will be called tetrahedron. Then carbon when forms 4 single bonds, its geometry or shape is tetrahedral. Now if anyone asks you what is tetrahedral shape, then you simply draw this cube. Again I am drawing it for you. Then put this carbon in the middle of the cube and show two bonds to this corners and 2 bonds to this corner. Whenever, sorry, hmm, 2 bonds. Okay, I'll redraw it. I'll redraw it. Show the cube. Put carbon in the middle of the cube. Then show 2 bonds to this corners and 2 bonds to this corner. Like this, you can connect it. Then these bonded species can be hydrogen, can be chlorine, or can be anything. But whenever this carbon is forming 4 single bonds, then its shape is what? Tetrahedral. Now let's consider few details about carbon. Whenever carbon is forming 4 bonds, you can draw it like this: H, 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 H. But this is not true representation of structure, just because it is not showing complete characteristic of this CH4 molecule, because this CH4 molecule is essentially what? It is essentially a tetrahedral molecule. Then let's consider carbon. Again, our discussion is on carbon atom. This carbon atom has one unique property called catenation. Now, what is mean by catenation? You must have heard about catenation. Catenation is self-linking ability of carbon. This self-linking ability of carbon allows carbon to link with itself and link with hydrogen. Then this carbon has this unique ability of catenation, which makes or allows the carbon to link with other carbons in different fashions. Consider this structure C, 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 again. Now this structure, 8 carbons are there: 1, 2, 3, 4, 5, 6, 7, 8. Now these 8 carbon are linked with each other. Then in order to complete the valencies of carbon, this is molecule basically is hydrocarbon. Hydrocarbon. Now this hydrocarbon, carbon is having 3 bonds with hydrogen, this carbon, and 1 bond with carbon itself, thereby satisfying its valencies of 4. Then this carbon, you have to think, this carbon is already I have shown 2 bonds with other carbons. So this carbon will have 2 bonds with what? Hydrogen. And this carbon will have 2 bonds with hydrogen. Again, 2 bonds are complete. So 2 bonds with hydrogen, 2 bonds with hydrogen. Like this, each carbon will carry 2 bonds with hydrogen. But you have to understand this terminal carbon. This terminal carbon is having only 1 bond, so there will be 3 hydrogens attached to this carbon. Now, this basic hydrocarbon, why we call this compound as hydrocarbon? Because it is carbon and hydrogen. So this is made from carbon and hydrogen. Now understand that this molecule is called hydrocarbon because carbon and hydrogen, and we can show it in different ways. This molecule that we are seeing here, we can show in this condensed structure. Now this, whatever the molecule I am showing, is called basically, you have to study name in the lectures to come, but this molecule is called octane because it has 8 carbon. 8 carbon octane. Now this molecule, that is octane, what I have shown is complete representation. Again I am mistaking representation. Complete structural formula. Complete structure. Now this complete structure can be condensed into a different structure in terms of drawing only. It will be the same as molecule above but represented differently. Then can you understand this structure? Now consider the similarities and differences in these two structures. Here I am showing carbon-carbon bonds. Here also I am showing carbon-carbon bonds. But these 3 hydrogen, instead of showing them separately, I have drawn 3 hydrogens collectively to this carbon, because these 3 hydrogen belongs to this carbon. These 2 hydrogen belongs to this carbon, so it is what? CH2, 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 CH2. Last carbon, these 3 hydrogens are condensed like H3. It means the same, but it is what? Condensed structure. Then